innovative solution for smart city, enhancing mobility and urban sustainability. And today, the first session was handled by Dr. K. Annamalai. The topic of impact of electric and autonomous vehicle in urban environment. Next, the title will be presented by Ms. Jyoti, Senior Head IBM. And then our topic is smart sensors and IoT for energy efficient building. Here I welcome Jyoti ma'am for our presentation. And then Jyoti, a small introduction that will be given by, I request Ms. Divya Lakshmi, Assistant Professor of Computer Science Engineering, to introduce about our guest, Ms. Jyoti.
Thank you, ma'am. Good evening, everyone. It is my pleasure to introduce our esteemed speaker for today's session, Ms. Jyoti Segran, with 26 years of experience. Her technical journey began at ISRO, where she developed telemetry systems, showcasing her engineering acumen in highly specialized fields. Her education in electronics and communication, completed by an MBA in project management, set the foundation for his versatile career. At HP, she spearheaded quality engineering innovations, collaborating with diverse teams across geographies. She played a pivotal role in advancing women in leadership and mentoring talent as part of corporate initiatives. Throughout her career, Jyoti has exemplified a commitment to excellence by adopting data-driven approaches, fostering innovation, and building robust IT solutions. Her experience across industries and certification in Agile, Six Sigma, and PMP make her a transformational leader capable of aligning technical capabilities with the strategic objectives. At IPM, Jyoti leads the development of Z firmware, simulators, and diagnostic tools, ensuring seamless integration of hardware and cloud platforms. Her expertise in managing I390 systems, hyperlink protocols, and network diagnostic drives improved reliability and system performance. She oversees cross-functional teams to align IT deliverables with business goals, fostering innovation and operational efficiency. During her 14-year tenure at HP, Jyoti transformed QA processes, achieving a 63% reduction in turnaround time with advanced text automation using simulators, bots, and CI/CD pipelines. She redeployed 60% of resources to strategic projects through optimized workflows, contributing to organizational growth. Her leadership resulted in 40% increases in customer-centric test scenarios. As an HP Global Ambassador, she led global initiatives and earned over 70 awards for excellence in cloud programs and quality deliverables. At GE Healthcare, Jyoti integrated advanced IT systems into healthcare frameworks, ensuring compliance with industry standards. She deployed innovative solutions to enhance operational efficiency and streamline system functionality, demonstrating her ability to manage complex projects. As a scientist at ISRO, Jyoti has developed telemetry and command systems critical for satellite missions. Her work in digital communication systems ensured high reliability and efficiency, showcasing her engineering expertise in mission-critical environments. At Mises Banking Systems, Jyoti delivers scalable IT solutions for global banking operations. Her role focused on enhancing system performance and integrating technologies, underscoring her versatility across industries. We are honored to have her with us today to share her valuable insights on the topic, smart sensors and IoT for energy efficient buildings. I extend my warm welcome to Ms. Jyoti Segran. Welcome, ma'am.
Yeah, thank you so much, Dr. Vijay, as well as Lata ma'am. Thank you for giving this opportunity. This is the second session I'm taking in this FDP program. So the overall, the FDP program, the title, it is a very, very highly wanted and then highly needed topic at this moment of time, the smart cities and mobility. Excellent topic, Lata, and then very good, and then your giving the innovative and the title also innovative solutions for smart cities. So the intention for this FDP program, what I understood from the Lata is, you all the professors, lecturers, you all have to take it up this topic each and every session. Lot of eminents are coming and giving, and you have to include in your regular day-to-day BOS, Board of Studies, and you have to make it as a syllabus, as well as you have to a lot of research areas. People now the government also wanted the research areas in this line. So thank you so much for this opportunity. Anyway, introducing myself, it is not needed much. Anyway, she covered, Vijay Lakshmi covered overall a lot of things about me. So right now I am working with the IBM, and then overall 25 plus years of experience and different areas. So we anyway, in the end of the session, I'll pass my LinkedIn ID to Lata, so she will pass on to you. So along with me, I have Kishore. Kishore, next slide. He's the person, he's the product owner in Coimbatore, and he's the person because since I have given a one session, he's my mentee, and then he's also specialized in IoT and cybersecurity and blockchain technology, and most of the Gen AI and automation related activities he is doing, and he's one of the all-rounder in the all-rounder performer, and then lot of top talent in the college where he studied. So I wanted to give this opportunity, and in between I'll also pitch in the because complete slides made by me and Kishore, and then we have discussed together, and then we have done. So I want to give this opportunity to him, and then in between I'll pitch in, and I can take over to you. Your questions, any interactive sessions, we'll make it. So I'll give a break here because I know that today the whole, I have seen the previous session, it was around 140 slides. Dr. Annamalai sir has taken you through that. And then you have very, very patiently, you are listening, and then you understood each and every parameter of the slides. Mainly what I wanted to look into that is, what I wanted to from you here is, here our slides are, we are having around only some 15 to 20 slides, but we'll give a pause in between. If you have, we'll make it very interactive because this topic is very, very interesting topic. We'll make it very interactive. Okay. So this is nowadays whomever is building the any building nowadays everybody's dream is to construct one house. So people will go and then construct the houses. So a lot of smart buildings they wanted to make it. So that very interesting way I want Kishore to take you through that. In between I can pitch in. Thank you. It's over to you, Kishore.
Thank you so much, ma'am. So, very good evening, everyone. So, we have this wonderful topic, smart cities and the IoT. So, we have heard of this IoT topic everywhere. So, what is the smart sensors or this normal sensors? Where these things already play in? So, before jumping into the topic, I wanted to know the tempo of the people who are here. So, before that, myself, I'm Kishore, as Jyoti ma'am said. I have also, I'm an inventor of an smart sensor that is used for the UPS batteries, what we use in the household as well as the solar grids. I have also done the projects related to the IoT and the communication protocols using Node-RED and automations using the RPA technology, etc. So before jumping into the topic, I wanted to just have an interactive question with the audience. How many of them are using your smart assistants like Alexa or Google Assistant or Siri or any other home assistants that you're using it every day? Anyone? All right. So most of them will be using such things in our households. It's being a common one. Why? Because it eases our life with better automated flows. It wakes up us. It interacts with us. It makes our job easier so that we can focus on other jobs in a better way. All right. Before jumping in to the smart sensors, let's understand sensors. So example, let's take MQ2 sensor. This is a basic the atmosphere CO2 level and the nitrogen level sensing sensor. It detects the smoke and alerts accordingly. So this is a basic sensor. What it has, if you see, inside this there will be a sensing element. Sensing element is nothing but it can detect the changes in means of physical changes. It can detect. It can be a temperatural change. It can be a humidity change or whatever. So in this MQ2 sensor, we'll be having a sensing element. It detects the physical change due to the fumes which we have. For example, there isn't too much of LPG leak in a kitchen. So we can identify with this MQ2 sensor. This detects the physical change and converts them into a digital signal. So this digital signal will go to a signal processor. Here we will having a signal processor. This signal processor, what it does, it will amplify. It will amplify and categorizes the data accordingly, and it just sends the data to the other devices through the any other microcontrollers. For example, we have Texas Instruments microcontroller. This kind of microcontroller it doesn't have any kind of wireless protocols. But if we consider using any advanced microcontroller like ESP32, this kind of microcontroller, what it does, it will receive data from these parts and it processes it at this level. And then it transfers to the cloud or any other displays like a matrix display or your mobile phones, etc. So this is what happens inside a sensor. Yeah, inside the sensor, these things doesn't come in. So this is sensor, so this thing doesn't come in. So now coming to the smart sensors. Okay, now we have this sensor. What if we have this inside this one, also this display inside this one? It will be awesome, right? Not only that, it can process according to the patterns on the algorithm. What we use the common term, there is the trending word, there is the AI. So this thing also incorporates the AI, that is the smart sensor. So okay, I have a small gist over the smart sensor. It is nothing but it is a sensor with a built-in microcontroller with a connectivity. And the connectivity is nothing but any other protocol like Wi-Fi, Zigbee, or any other Bluetooth, or Bluetooth BLE, anything. So these things comes under the smart sensors. Why we use the smart sensors? First of all, what's the need of this smart sensor basically? Yes, here we use this IoT concepts for more than a decade in the back. Now all these sensors are really out of date because of the new technologies what we have now. That is the AI, the blockchain technologies, and more of the interactive uh, controllers what we have now. Okay, these smart sensors, what actually does it? It collects the data and it stores it itself, and then it checks for the pattern. For example, if the human body temperature needs to be in around 20 to 25 degrees centigrade, the atmospheric temperature should be in 20 to 25 degrees centigrade to keep it as a normal temperature. So what it does, the sensor just keep on getting the data from the sensing element and it stores. And when there is an abnormality, it will check for the pattern. Okay, this is a daytime. The weather is around 30 degrees centigrade. So it is actually normal. So it can rise a 5 degree. All right. So that is fine. So we can just increase the AC level or the fan. You can turn on the fan. That is one part. In the next level, it is actually night and the volume of the persons in a room is higher. There are nearly 10 members in a room. So what we have to do now, the automatically room temperature will be rising. So the smart sensor will automatically detect that there are abnormal rise in the room temperature. Take it, this is around 30 to 33 degrees centigrade. So this is not normal. So we need to use the ventilation systems and the air conditioning system in higher level. So which comes in the play of this smart sensors. So this also helps in the real-time monitoring, where we can check for the data in through the smart devices. If there is a fire alert, the temperatures may go beyond 80 or 90 degrees or 100 degrees. So in such situations, we can, if the smart sensor can understand the situation that the house is under a fire or a company is under a fire. So if it's so, it can understand the situation and act upon. So that's where these smart sensors needs a place. Okay, so till far we can understand the sensors and the smart sensors, all those concepts. If there is any doubts or any clarification needed in between, you can just unmute yourself and jump in for a question. All right. If there is no question, and by the way, am I audible and the screen is visible? Is all correct, right?
Yeah.
No, kind of.
You are audible, and then it's good.
Great. That's okay. So now let's jump to the next topic. That is the IoT architecture, the very important topic where how this IoT things actually work. Okay. First of all, what happens? As I said prior, this thing is the first part. It senses the whatever changes happening inside our surroundings, the sensing layer. Next, we have the network layer. Here comes the processing. Here we have two subdivisions. These two layers, the layer 2 and layer 3, can be layered upon. It can be even a one layer, or it can be three layered, or it can be switched over. Like two will be in under and three will be in above layer. It actually depends upon what kind of sensor what we are using. So if it has an in-house processing unit, then it will be 1, 3, 2, 4. If it doesn't have an in-house processing unit, it will be 1, 2, 3, 4. Now let's understand with the basic layer, that is 1, 2, 3, 4. So now we have the network layer. After this part, just identify the data, it sends to this ESP32. ESP32 is actually, it has a Wi-Fi and also it is actually kind of a microcontroller. This ESP32 with this Wi-Fi signal, it sends the data to the processing layer. What is the processing layer? We'll be using this edge computing or any of our cloud-based applications. It will analyze the data, and it processes it, and then sends the data to any visualization, or else it triggers to any of the activators like this relay. Uh, uh, Generally, what a relay does, it just turns on something or it just triggers some action. So this happens in a IoT architecturing layers. In terms of a smart sensors layers, this two layers, this 2 and 3 will be combined together. So here it comes this ESP32. It will be also having the Wi-Fi module, all as well as the microcontroller in itself. So we'll no need of much of edge computing or any other computing in any other devices. We can do all this task in one device, that is using the on device itself. So we no need to leverage any of the AI things happening in the edge computing. Okay. Next to the applications of smart sensors. Um, Smart sensors are really everywhere. These smart sensors actually came in a decade ago. Before the AI, just the word just got too much of trend. It was in the market. Okay, where we are using the smart sensors mainly in terms of the smart cities and smart buildings. As we are focused, we are pivoted our topic towards smart buildings. We have this four important applications. What is the water management system, and is the light management system, and the access control, the security, on those factors, and is the air conditioning, heating, and those temperature related monitoring systems. These four things are so vital for a building to be in optimized state. So these four comes under the main topic for us. So we'll be diving in deeper regarding this. Other than that, this smart sensor comes in everywhere. For example, in the healthcare industry, it is very vital for everyone to wear an smartwatch or kind of a device to monitor their situations accordingly, and it triggers the action automatically. For example, the Apple Watch automatically detects your heart rate, and if it is in an abnormal situation, it automatically triggers a call or a situation to the hospital or the doctor in a such a way. So all such things happen inside this healthcare industry and manufacturing, the IoT industry, IoT thing. In that, all these things are automated to prevent any other labor being injured due to the manufacturing sector. All this can be automated by this robotics and the smart sensors by keeping the accuracy rate in a very higher level. And mainly, most of the automotive industries, what we have now is manufacturing with this. In the last session, Dr. K. Annamalai actually spoke regarding this fuel cells, batteries, and all those things. To monitor all those factors and to stabilize all those things, these smart sensors are highly required to make all this electrically dependent things safer. All right. Next, we have the defense part. Defense part, most vital autonomous vehicles we have for the aviation, and we have for the marine, all those factors. These different vehicles will be using the smart sensors to identify the any other things in interior without intervening a human being inside. All right. Okay. Yes. Then the final part, that is the space and the ground exploration. Nowadays, we have seen rovers going inside the moon, Mars. We have explored most of the parts in the space. Now we are exploring the ground in the most of the way. For all those things, the smart sensors play a very vital role to take action upon in their own, instead of a human or an other artificial intelligence giving them a command. It processes itself with using the machine learning and the algorithms with the patterns what we usually follow, and it does the process. All right. So we'll jump a deep inside these four topics. That is water, light, security, and the air conditioning. All right. First, we have this water management system. Okay. Basically, the very most volatile resource in our world that needs to be addressed in a sustainable way, that is self-sustainable way, is water management. The thing is, we may be overutilizing it. We need to secure it. Even if we are using in a very low volume, it may go wrong in any other ways that we have not imagined of. For example, a leaking water of a tap can just vanish your tank of water within 12 hours or 14 hours. So that's how it is so minute to create a change. So these minute level of changes can be easily addressed with this smart sensors using the highly efficient flow monitoring sensors. What it does, it actually has a propeller inside the pipe system what we have. So inside the pipe system, it will, if you just open a tap, it will start rotating. So it can understand the pattern. Okay, one tap is open, so the pressure what is going and the water force what is going into the pipe, the volume what is used is according. So it will understand the situation and store the value. Now, two pipes are open, so it will understand the value. So by keeping on understanding the values, it will learn by itself as a machine learning unsupervised learning factor. It understands the algorithm, and whenever there is a leak, for example, there is a continuous flow of water for around 12 hours. Now, this sensor will automatically understand the situation that there is a leak somewhere, then it will notify the user accordingly. So this is where the pattern kind of things comes under for the smart sensors. Another one is water flow monitoring system. This is very common nowadays. In most of the cities, there is a meter being installed inside the households so that they can see whether how much of water they are using, whether they are over consuming according to the volume of their people what they have in their house. All those factors comes in. All right. Now, with this, all those things, we can also compare with our real-time usage. For example, it takes nearly around, for an approximate value, it's take around 100 liters for four people for a week. So whether we are over consuming or under consuming, how much amount of water we are saving, all those factors we can monitor in real time, and we can address if any of the leaks, any of the water related things are happening inside the household or a commercial building, we can address it very easily. All right. Okay. So coming to the smart lighting system. Smart lighting system are very common nowadays. If you take nearly 6 years back, Philips came up with a lot of lighting products focusing on the Indian market with 1 million types of colors that can be monitored and that can be controlled with your mobile phones and all those things that can be operated with your voice assistants, etc. But that is not actually a smart lighting system. Actually, a smart lighting system will require a separate two devices. One is a device which needs to be fixed outside your building, and another device that needs to be fixed inside. That is your actual light. What happens? The sensor which is outside your building senses the amount of light intensity which is in the exterior. So it matches upon, and the another sensor which is inside the building, it senses amount of light which is inside the building. So it will reduce. It will do the math, and it will calculate how much of lumens of light is required to match the exterior condition or reach the optimal lighting preferred. So even so, if it happens for every time, we will be having a constant type of lighting systems inside the office or inside our households, so that our eyes will not be strained much. It will be in same optimum level. Our retina will not open to an extent. It will be always in a constant level, so that it will not be much stressed due to the lights. So, so this thing is actually a smart lighting system. According to the occupants, for example, I enter a room, so I need a light. If I'm not there, obviously I don't need a light. So according to such situations, the smart lighting systems identifies whether there is a motion inside a room, and it turns on the light or turn off the light accordingly. So it's not a big deal about the lighting system, but the impact what it does is very huge. The amount of energy what we save is also very huge with the smart lighting system. Next, coming to the safer buildings, right? Nowadays, whoever works in a corporate or even the faculties, we will be using the punch-in machine, the biometric machine. It is so common to maintain the attendance. We used to go punch in. If it is an yes, we'll go inside and we'll work. While work is done, we'll come out, we'll punch out and go. That's it. So that is a basic level of access control systems. That is also actually not a kind of a smart sensor operated smart building. Actually, what is a secured thing for a smart sensor based a smart building? What is actually required? Right. We would need to leverage the automations here. No need to use your thumb to punch in. When you walk in, the computer vision based programs, that is the cameras, will detect your face automatically. It will punch in it automatically. When you are enter, it will automatically turn on your computer, and it will keep your systems ready. It will turn on the air conditioning systems ready, and it will unlock your doors automatically whenever you pass through. So all these things come upon this makes the smart systems. All right. So apart from this, for a secure building, we would need this safety measures. For example, in the first slide, the second slide, I spoke about the fire instance. What may happen here? If there is a rise in the temperature being found, this will automatically understand there is a fire inside the room. It will automatically activate the HVAC system. That is, it will open all the windows. It will open all the doors. It will turn off the air conditioning system if it requires, as it is volatile, to turn on the air conditioning system in fire situations. It will make the people to exit faster way with the navigation system, with the light alarms everywhere. It will trigger the fire alarms and everything's in a sequential way, so that there'll be no intervention, human intervention to control the situation. It will make this complete thing a self-sustainable. Okay, that's where this smart building ends. Next, this is very important thing in terms of smart buildings. That is the heating, ventilation, and air conditioning optimization. That is HVAC optimization. For example, you go to an exhibition. For example, there are nearly 50,000 people inside a huge hall. You enter there, you find the temperature to be cold in every time. Though it's a huge hall, everything is so optimized, and even the volume rises or volume lowers, the temperature remains so constant. How does it happen? That is only using this HVAC optimization system. What is this? As I said previously, it will calculate for the volume of the people. It will understand the temperature, and accordingly, it will turn on the air conditioning system. It will lower the temperature accordingly, and in colder regions, it will turn on the heaters accordingly. If there is a ventilation needed, it will open the ventilation system using the relays or the actuators accordingly. So this kind of HVAC system plays a very vital role in terms of this smart buildings. All right. So we have seen nearly four kind of major this kind of things, that is the applications of the smart sensors. All these things lie upon one other thing, that is the real-time monitoring, energy monitoring. Here we will be conserving most of the energies in a very large way. All these things can be monitored in a single console, so that we can have a justified view whether we are over consuming or under consuming, how much we are saving, how much carbons we have saved. All those things we can see for a better sustainable future in the upcoming years. All right. Apart from this, real-time monitoring also includes real-time controls, which is so common. Can use your handheld devices to control all the applications. Even we have smart switchboards which can be used to control all these things. It gives a widget of all this analytics and data in very easily understandable charts. Okay, so we have completed till the smart sensors, and we have also seen about the applications of it. Now, all these things lies upon is it is so much interrelated to create a smart building. All these sensor parts, the applications, four applications, what we have seen is so vital to create an actual smart building. So you can just connect yourself. All these four topics is highly interrelated. All this will require a very common kind of a technologies here. That is, one is the IoT, basically, yes, the protocols what we need for the connectivity for the smart sensors to communicate with one another. For example, a temperature smart sensor communicate with the water smart sensor, or if required, any of the door smart sensor, any of the things, it can be automatically communicated in a very effective way. All right. Next, we have the analytics. All these data will be highly required to train your machine learning model according to your usage. So these data will be automatically analyzed for to accelerate in a faster way. This will be also used for the urbanization factors. For example, in Coimbatore, people are using in such a rate, and we would require these kind of features, a large water tank, or to increase the amount of power grids in the Coimbatore supply. All those things can be pre-calculated with this data analytics, and this can be embedded in the urbanization factors too. Next is the automation factors. All these things can be automated as a situation. Okay, let's have a small situation analysis. For example, I have a meeting tomorrow. I'm going to sleep now peacefully. My house is completely automated. Take that as an example. I'm sleeping now. I have kept an alarm for 6 a.m. Think how it will be. You are sleeping, automatically an alarm, a smooth playing alarm starts to ring. Slowly the curtains open automatically. Your coffee machine turns on automatically, and the coffee is going to be ready in 2 minutes. And the toast is also be going to be ready in 2 minutes. It's ready. Your water heater has already turned on 10 minutes prior, so you can have your breakfast and get started to get ready. And everything is set, so you just wake up so peacefully with the curtains open, natural light falling on your face. You peacefully wake up with the smoothing music. Then you have your coffee, your bread, and then you go for your other things. Then you go to your office peacefully. Take another situation where you need to wake up early and you have to go. I'm taking in terms of bachelors. In other situations, you will have some other people to make coffee and bread too. All right. In other situation, consider you are single in the house. You are getting up with no smart building integrations. You wake up with the same alarm sound from your mobile phone. You open the windows. You see outside, and then you turn on the geyser, and you turn on the toasting machines, coffee machine, and you have yourself, and then you go to a bath. So it will take some time. That is not in an organized way. So in the first situation, the person will be so organized, he'll be so peaceful, so that he can focus on the jobs which he needs to. In the time, he can revise what all the things he needs to be addressed in the meeting. Whereas the other person will be wasting his time in doing his daily routine activities. These smart sensors comes in actions, these smart buildings comes in actions only to elevate our situations, which we do in a routine way. So there are two kind of peoples you always say. One is we will say it is as a laziness, but you will think it as a convenience. It's really upon you whether how you use it. All right. So, so now we have spoke about smart sensors. If there is there are any questions, please pitch in. So we'll be after the question session, we'll jump into the smart buildings, which will be a really interesting one. All right. If so, we'll happily go to the smart buildings. Okay. What is actually smart buildings? I've said it just previously with the example what I gave you. These smart buildings are highly responsible for a smart city. to enable. We have a lot of plans in India to create a smart city and all those things, but it is not possible without creating a smart buildings inside the cities. This this smart buildings are highly vital to understand the environment and do the urbanization accordingly. So this is why we need the smart buildings. So okay, how is a normal building different from a smart building? Before jumping into this, I would like to take you to a video, as I have already spoke nearly 30 minutes, I think so. Let's have a small 2 minutes video. It will be very interesting. It is actually a wonderful playlist by Cisco partnered company called as VAM. It will be very interesting. Yes, we'll just listen to it. And is my screen visible? Is my audio system's audio edible? Is it okay?
You play, then only we'll come to know.
Ah.
Because we are able to see. Yes, video is visible.
All right. So I hope you understood the context of this video. This is actually what is a smart building is. So this is what we actually need in all of our buildings, right? Okay. Okay, now you could have gotten a comparison from this Eloit video. This playlist is actually really awesome in terms of IoT. You can recommend to your students, or even you can watch the full playlist. It's around 10 videos, nine videos. It completely explains about all the IoT things which can be implemented. The wonder factor is they have made it really 9 years ago, and it is really still of Indian buildings require these. All right. So main things what these normal buildings want over the smart buildings. One is the technological integration. We would need to implement most of the technologies like the generative AI, edge computing, this IoT systems, and all those things. Another one is the energy efficiency. We must prefer more energy efficient devices. For example, instead of using a CFC bulbs, we have already switched to the LED bulbs. So whichever is more efficient, we have to adopt those things and we have to conserve it and use it in a very conservative manner. Another thing is security. Automatically, it should be a an unsupervised security model, and it should be in a very structured way. All these things need to be implemented in a smart building. Another thing is the adaptability, how we take up and how we use these things, how much it is actually helpful for the people, how they perceive it. All those things is important. How much it is cost efficient is other factor. Maintenance, convenience, comfort, etc. And the connectivity with the global technologies, etc. To understand more deeper, we will have this another video that is the business related IoT thing. That will be also very interesting. Let's take a look on this.
Are evolving. New opportunities are inner systems are specifically tasked with the challenge of providing safe and secure settings, network connectivity, functional spaces, and an IoT-enabled environment to achieve improved business productivity. This video provides insight into these environments and addresses foundational elements required to migrate to a smart building platform. The first step in creating a safe and secure environment is through risk management, which can be achieved with a 5-layered physical security approach. Deploying a layered security strategy can provide you with the ability to deter, detect, deny, defend, and detain at every layer of your commercial building, including the property perimeter, reception, floor levels, technical spaces, and specialized zones. These areas typically adopt a variety of security solutions, including network video surveillance, integrated access control, intrusion detection, and fire protection systems. More than ever before, a high-performance structured cabling system plays an essential role in operating a smart building. Without it, you cannot achieve the best practices required to support multiple applications, cope with increased bandwidth, and eliminate network downtime. Creating versatile physical layer connectivity is dependent on well-designed network flexibility, a universal cabling topology, media selection, wireless mobility, and consideration for multi-application support. This suggests the need for an open system platform where hardware and software work together to increase the productivity and efficiency of the network. Social and economic drivers are placing a larger focus on how workforce behavior can be improved with technology. This presents many challenges, including supporting a BYOD environment and enabling collaborative business communication with seamless network availability. Workforce productivity can be achieved through network accessibility, scalable growth, unified communication, and multimedia engagement methods. Utilizing in-building cellular coverage such as DAS and small cell technology, seamless Wi-Fi connectivity, collaborative AV solutions, and communication through digital signage. With more employees concentrated in smaller spaces and increased demand for dynamic, collaborative areas, the need to optimize space is important for the productivity and efficiency of employees and of the building itself. Commercial buildings contain a number of functional spaces, including the main reception, common work areas, meeting environments, private office locations, technical rooms, and various specialized zones. Mobile and fixed network connectivity, professional AV and lighting solutions can all assist in optimizing real estate effectiveness. Enabling the Internet of Things in a commercial building allows you to analyze your environment and make real-time adjustments to improve efficiency and productivity. A truly smart building will address the challenges of open architecture design, supplier integration, and migrating to an IP platform. A BIoT-enabled environment simplifies the task of managing risk, improving network performance, enhancing workforce productivity, and better space utilization. The 5 sensors that enable intelligent buildings include environmental monitoring, visual management, communication enablement, security integration, and network connectivity.
All right. So from here we could have got an idea how these things come under this maintenance, sustainability, and connectivity factors. How an building actually requires a networking system for a better smart building infrastructure. So jumping into the smart building trend. Here I spoke previously about this artificial intelligence, edge computing on the sensors, what we have written as smart sensors. So how it is actually increasing, how it is actually needs to be addressed by us. For now, all of our students are actually learning this IoT or learning this artificial intelligence or learning the cloud computing separately. But to make something together, they must ultimately know all these factors, right? They must know to enable an AI integration into this IoT. They must know how to leverage the usage of cloud for this to achieve the cloud computing factors. They must know how to create an smart sensors using this basic level sensor. That is where a real innovation and intelligence comes in. So that is where we want our students to drive towards. So to drive all these IoT factors, we would majorly need these three things to be addressed. That is the absolutely the artificial intelligence. No need to learn this things in a deeper. At least they must know to leverage the generative AI yeah, options, that is using the APIs of the all the LLM models, or they must be so much enabled to utilize the uh, cloud computing of the AWS, Azure, or kind of things. Next, with the advanced sensors, we would have learned about this MQ2, MQTT sensors. We will have this relays. We will have all this kind of ESP32 sensors, etc. But where all these things comes up, these things must be integrated all together and to be given as a unified data. So that's where all these trends it's taking to us. So before they learn all these protocols, the architecture of this IoT, the student must be given an idea of what are these and how to integrate these technologies inside this IoT so that they can build a solution towards this smart building. Right. Now, this is the same part what we spoke with the smart sensors, but we will just sync up with the building concepts. Now, let's have the same situation. Now, we have integrated the whole house with the smart sensors. It is completely enabled, and now all this thing is a complete smart building, so that it will be more energy efficient. How it will be energy efficient? As I said previously, we are conserving the lights and the HVAC optimization, the water management systems, and the security systems in an automated way, in a self-sustainable way, such that it automatically identifies the situation and acts upon. Next, the real-time monitoring. Even if we want to do some changes and to see the changes what has happened, we can use this leverage the visualization things. Next, the occupant comfort. All these things actually gives us a huge convenience where we can leverage it in a very other beautiful way than what we use in other parts. It will create a situation to work in a peaceful manner. It creates a good environment to work in a peaceful way. All these things will be taken care of something which is automated. So it will be awesome. Right? That's it. Next, these things are known benefits. What will be beyond this energy efficiency? Because we are we are under this FDP full of sustainable development, all those things. But how far it is way more important than the energy efficiency. If you take the situation of our world now, the world doesn't need sustainability much. It needs self-sustainability. The solutions or innovations what we are making need not to be sustainable, because what we have is already mostly sustainable. We must make it self-sustainable. How it is different? So what the systems, the automation, the flows what we make with these systems will make it more self-sustainable. Such a way there will be no need of any other human intervention, or it will be completely unsupervised learning mechanisms. Next, we have this urban planning. As I said prior, it will be very useful for the smart cities integrations and planning for the expansion of the cities and all these things. For example, let's say like in a building, there are nearly 60 families in an apartment. They all purchase a milk. through an application. Instead, they could have opted this urban planning thing. It could be easily sourced from in a shorter duration, so that the transportation will be a saving factor. So automatically all those things will come in. The energy efficiency, sustainability, and the cost cutting, everything will come in. Next is the climatic goals. We all know day by day, the average temperature rises so high, so which needs to be addressed very much quickly. These things can be very much monitored with this real-time monitoring system. We can take upon actions accordingly. We can even conserve it using the advanced technologies and innovations with the products what we have, without leveraging the better air conditioning system, without making damage to the environment, etc. Okay, from this whole session, let's have a takeaway that we need to implement these four key applications in our colleges or institutions or elsewhere where we are working. We can try to implement in a shorter way. We can encourage the students to create projects out of these four key applications, by which I'm 100% sure we can nearly save 40% from this. That is a minimum average of this whole study. But it is actually more than that if we are implementing all these factors. And our ultimate goal is to create a smart city out of all the smart buildings. All right. So now I have a small tool recommendation. It's kind of a simulation tool for IoT. We'll be using all these things, right? A Texas Instruments microcontroller, or a Raspberry Pi, or an ESP32. All this kind of microcontroller bit expensive. This is not expensive, but these two are much expensive. For creating a smart sensor, we would require a this is not a microcontroller actually. This is like a mini computer. So we would require something like this, which is actually a bit expensive. Proceeding in a large thing, it is not an optimized way. For example, if there are 60 students, we would need to procure nearly 60 kind of these things. It is not actually feasible. So this thing comes in. This tool is actually runs under the same micro Python or the C++ thing. Here I have a small template where there is an DHT 22 temperature control sensor, same like this one, connected to one ESP32. These two things are connected together. This will actually sense the temperature differences, and then it prompts us. It is a very basic level of sensing element thing. It doesn't even have a self monitoring things also. It will send the raw data to the ESP and it processes everything. All right. So here, let's try simulating it. We can do the actual connections, like we can use the cables, we can have the diagrams done coded way, or we can even use the stimulation accordingly. We can use any other modules too. We are using ESP32. Here we can see there is temperature is 24. It is actually a stimulated one, so it is not the actual data. So there is no change in a protocol, in a WebSocket manner. It will communicate in a um, mosquito protocol, so that it will automatically check for the conditions and revert back in a frequent manner. This is one of the situation. Here we have a n number of possibilities with this tool. It can be easily adapted. We can use the Arduino, or we can use the Pi controllers. We can use the C++ or the MicroPython. We can connect n number of other things too. For example, if I wanted to start something new project, I can create, I can add some elements which is highly used in the market. With this kind of tool, what can our students do is, like, they can create a stimulation of an actual smart sensor. That will be very easy to for them to. They can program it accordingly. They can make it actionable. They can check whether it is actually required for the market, and then they can do it as a project in a real time, and they can implement in their college premises or in their home anywhere else. By these setups, we can easily achieve this kind of smart cities in a very short span. So I thought of recommending this online tool. That too, it doesn't even ask you to download any of the applications too. It's so easy that we have to just type in the browser. It gives the complete access to you. You can simulate any code here. You can see the whatever needs to be happen in a very easy manner. Here, I have actually tried my sensing element here. This is my starting fact. That's why I wanted to recommend to you all guys. Right. Okay. So that's it. So I'm very much thankful for this opportunity to Jyoti ma'am and whoever concerned for it the opportunity. So we have nearly spoke about all the smart sensors concepts, the architecturing, the smart buildings and their infrastructures, what is smart buildings, how it is different from others, all those things. As a next step, I would require everyone to convey this to your students and ask them to create more and more of projects related to it. There are already existing projects created by Cisco and all other big companies, but they are lagging some of the factors like cost cutting and many other features which is actually not required by others. So which can be addressed by our innovative students so that they can create projects out of these 4 key applications which can be implemented in India in a faster way. So thank you so much. Open to the question and answer session.
Thank you, Kishore. Before winding up, one couple of things I wanted to tell. So in the whole world, mainly people are the government and then all the people are looking for conserving natural resources, right? Many sources like fossil fuels and other natural, even water, electricity, everything we have to be conservative. So otherwise, in the next generation, it will be a very tough. Even now, people are buying a waters in their home usage. So to avoid that, the smart sensors and IoT helps a lot. That's what that is a economic benefit, cost savings and boosting the economy. This is very important. Apart from that, health and well-being also. If you are more and more using the today, sometime back, Annamalai sir was telling more and more using the electric vehicles, we can improving the air quality and reducing the energy consumption and enhancing the quality of life. Then security, all the security features are in the smart. So that's why whatever the topic, when once Lata ma'am was informing about the topic, I was so happy because this is a topic now all the industry, all the education sectors have to move towards for the sustainability. So by focusing on the energy saving, we can create a more and more sustainable, healthier and economically stable world. So it's a win-win situation for Lata ma'am, it's over to you. Any questions? Anybody can, if you have any questions, please feel free to ask.
Okay. And Kishore for us nice presentation. Any questions you can post or unmute yourself and ask.
Okay.
Thank you, Jyoti. Thank you for the presentation. Thank you, Kishore, for your nice and wonderful presentation on IoT for
Smart
smarter,
homes, smarter buildings.
smarter buildings. I hope that video that was very useful. That it was built by using how the network has to be taken and how the security has been given. Wonderful session on this title. Thank you once again, Jyoti.
Thank you, everyone. Because it is a 6th day, everyone may be very tired of listening the IoT, smart sensors, and in the different areas. But finally, it has to yield a good results, Lata. Yeah.
So thank you, Jyoti.
Okay. Bye.
Thank you.
Participants, stay in the meeting. Let's start by 5:10. Stay in the meeting. We'll start by 5:10.
Feedback link for session 12 has been posted in chat box. Kindly fill the feedback.